Yeah, welcome back. Today we are going to discuss about stick diagram and rules of stick diagram to design Nmos, Pmos and Cmos. I hope that are you clear. Okay. Now first of all we will talk about what is meant by stick diagram. That is very important point you have to remember. Stick diagram is nothing but conveying the layers information. Conveying layers information. What are the layers we are having? Can anybody try to tell? Absolutely three layers: poly, yeah, diffusion and metal. Okay, these are the three layers we have to convey the layers information. If you observe that, how to convey the layers information in the form of color code or monochrome encoding. Is it clear? This is nothing but a stick diagram. Is it understood? Okay, now we will talk about the rules of the stick diagram for designing Nmos, Pmos and Cmos. Yeah, before going to discuss about the rules of Nmos and Pmos, just quickly recap the color code and monochrome encoding of MOS layers. Now you can observe that the polysilicon is going to be shown with this monochrome encoding. And what is the color? Red is the color. That's why I have shown with the red color. And if you observe the diffusion, okay, diffusion is going to be shown as empty. But for N diffusion, what is the color? Green color. For P diffusion, what is the color? Yellow color. And if you observe that the metal is which color? Blue color. Therefore, sorry for that, metal is going to be shown in the monochrome encoding in this fashion. I hope that are you clear. But the color is what? Blue color. Now if you observe that, we have to talk about the rules of Nmos and Pmos, okay, and Cmos. First of all, in this class we will talk about the rules of Nmos, Pmos, and later we will talk about the Cmos. Is it okay? Now you can observe that the rule number 1 we are going to talk about for Nmos and Pmos. Okay, if you observe that, we are going to talk about the rule. Yeah, this is the first rule. You can observe that when diffusion crosses polysilicon, okay, when diffusion crosses polysilicon, a transistor is formed. That is very important. Which one? When diffusion crosses polysilicon or vice versa, a transistor is formed. And if you observe that if the transistor is a n-type diffusion, then it is an Nmos. If the transistor is a p-type diffusion, then it is a Pmos transistor. And don't forget, both the transistors are what? Enhancement mode Nmos transistor. For depletion mode transistor, then you have to add a important thing. What is that important thing? Is implant. You have to add an implant here in this fashion. You have to add an implant. Is it clear? If you add an implant, then it becomes what? Depletion mode MOSFET. I hope that are you clear. This is known as implant. Is it clear? Now once again I am telling that when polysilicon crosses diffusion or when diffusion crosses polysilicon, a transistor is formed. But depending upon the diffusion, you can classify whether it is an Nmos transistor or Pmos transistor, and depending upon whether there is an implant or not. If there is no implant, it is an enhancement mode Nmos. If there is an implant, then it is depletion mode MOSFET. Depending upon the diffusion, it may be depletion mode Nmos or depletion mode Pmos. And coming to the second rule, if you observe the rule number 2, okay, when two different layers interact with each other, let us consider this is a polysilicon, okay, this is one layer, and let us consider this is metal, okay, this is another layer. When two different layers interact with each other, then there is a contact. Then I can tell this is a contact. Is it clear? When two different layers interact with each other, a contact is formed. I hope that are clear, all of you. Okay, this is rule number 2. Okay, these are the two rules very important for what? Nmos and Pmos. Is it clear? If once again I'm telling that if there is an implant, okay, if there is an implant, then it is what? Depletion mode MOS. I hope that are you clear. That is two rules, very important rules for Nmos and Pmos for designing what? Stick diagram. I hope that are you clear. Now you can observe that very clearly. You can observe very clearly. Okay, now we are going to observe the rules of CMOS transistor. Okay, to design a stick diagram. Rule number 1. In CMOS, don't forget, we are having both PMOS and NMOS transistor, and that too enhancement mode MOSFET itself. Therefore, we required a separation line. That separation line is known as what? Demarcation line. I hope that are clear. The word demarcation represents separation, isolation. Okay, the transistor above the demarcation line, is known as PMOS. The transistor below the demarcation line is known as Nmos. This is the first rule of CMOS. Okay, now we will talk about the second rule. Now coming to the second rule, if you observe that The VDD or VSS power supplies are going to be shown with the help of metal, and don't forget this is a cross mark. Okay, the cross mark represents substrate bias. Okay, this should be very important to give VDD or VSS connection. I hope that are you clear. This is rule number 2. And coming to the third rule, you can observe the third rule very easily here. Okay, I'm going to show with the pictorial representation. This is what demarcation line. The third rule in Cmos is the diffusion should not cross the demarcation line. The diffusion should not cross demarcation line. This is not correct in the Cmos, but the poly and metal may cross. This can be allowed in the Cmos. Poly and metal may cross, it can be allowed in Cmos. I hope that are you clear, all of you. Okay, this can be allowed and it can't be allowed. That means the diffusion should not cross demarcation line. These are the three different rules when compared to Nmos and Pmos. And the similar rules here is these are the similar rules when compared to Nmos and Pmos. When polysilicon crosses diffusion, or else when diffusion crosses polysilicon, the transistor is formed. And when two different layers interact with each other, when two different layers interact with each when two different layers interact with each other, let us consider this is a polysilicon and this is a metal, as we have seen in the Nmos or Pmos. When two different layers interact with each other, what is going to be formed? Contact is going to form. Is it clear? That's it, guys. These are the 5 rules you have to remember for designing Cmos stick diagram, and the 2 rules. These are the 2 rules you have to remember for designing what? Nmos and Pmos stick diagram. Is it clear? Thank you very much. Have a nice day.